Well, it's time to talk about areas of trapezoids, rhombi, and kites. And this is the content standard and the mathematical practices in our assignment today. Previously, you've found the areas of triangles and parallelograms, and now you're going to find areas of trapezoids and the areas of rhombi and kites. One new vocabulary word, height of a trapezoid. Earlier, you learned that a trapezoid is a quadrilateral with exactly one pair of parallel sides. These parallel sides are called bases. The height of a trapezoid is the perpendicular distance between its bases. So as you see, the height of the trapezoid is perpendicular distance between its bases. Find the area of steel used to make the side of the razor blade shown below. Well, using the formula that the area of a trapezoid is equal to 1/2 of its height times the sum of its two bases, we are going to substitute in, the height is 1, one base is 3, the other one is 2 5/10 of a centimeter. So we add these two together and divide them by 2. 2 75/100 centimeters squared. Okay, time for you to check your progress. So pause the video, work the problem, then come back and check your answer. If you took 1/2 of 11 times 30 plus 25, you'll get 302 5/10. Miguel designed a deck shaped like the trapezoid shown below. Find the area of the deck. You might want to make a drawing of this figure to make it easier as we move on and solve the problem. So you're given a trapezoid. One base measures 4 feet. It has a height of 9 feet and a third side that measures 5 feet. And we're asked to find the area of the trapezoid. So first of all, we need to find the measure of this other base. So we draw a segment to form a right triangle. The triangle has a hypotenuse of 5. One of the legs we'll name L. And we know that this is 4 feet. So we can use that to find the measure here by using the Pythagorean theorem. So that measure is going to be 3. By segment addition, we know that L plus X is equal to 9. We've discovered that L is 3, so we know that X is 6. So the width of the rectangle is also the measure of the second base of the trapezoid. So we substitute in what we've found now into the formula for area of a trapezoid and simplify. So the area of the deck is 30 square feet. We can check our answer. The area of the trapezoid is the sum of the areas of the right triangle and rectangle. So the area of the triangle was 6 square feet. The area of the rectangle is 24 square feet. So the area of the trapezoid is 6 plus 24, or 30 square feet. Okay, time for you to check your progress. So pause the video and find the area of the carpet that's going to be needed to carpet this room, and then come back and check your answer. So if I drew and separated this into a right triangle, I know that this measurement would be 8. I know that this is 10. We're trying to find this measurement, which 8 squared plus b squared is equal to 10 squared. B ends up equaling 6. So I know this part is 6. 14 minus 6 is 8, so I know that this portion is also 8. Then I can go back and substitute into the formula for area. Area is equal to 1/2 of 8, which is this height, 8 times 14 plus 8. 14 plus 8 is 22. 4 times 22 is 88 square feet. Recall that a rhombus is a parallelogram with all four sides congruent, and a kite is a quadrilateral with exactly two pairs of consecutive congruent sides. The areas of rhombi and kites are related to the lengths of their diagonals. This is what's being stated in the key concept. The area A of a rhombus or kite is 1/2 the product of the length of its diagonals, denoted by D1 and D2. So let's find the area of this kite. Well, we know the area of this kite is 1/2 of the product of its diagonals, 7 and 12, so substitute in 42 square feet. How about finding the area of the rhombus? Now notice that this 7 is just half of this side, so this entire diagonal will be 14. This entire diagonal would be 18. So 1/2 of the product of the diagonals, and the area of the rhombus is 126 square inches. Okay, time for you to try your hand. So pause the video and then come back and check your answer. This one was very easy, wasn't it? 1/2 of 13 times 9, so 58 and 5/10 square feet. Let's try the area of a rhombus. So pause the video, then come back in a moment and check your answer. You just had to do a tiny bit more work. 18 times 20 times 1/2, 180 square inches. You can also use algebra to solve for unknown measures in trapezoids, rhombi, and kites. So we're going to use what we know about area to solve this rhombus. One diagonal of a rhombus is half as long as the other diagonal. If the area of the rhombus is 64 square inches, what are the lengths of the diagonals? So we can use x to represent the length of one diagonal, and the length of the other is half of the first one. Use the formula for the area of a rhombus. Substitute in x for one of the diagonals and half x for the other. And simplify. 1/2 times 1/2 is 1/4. X times x is x squared. Multiply both sides by 4 to get rid of your fraction, and take the square root of both sides. So the lengths of the diagonals are 16 inches and half of 16, which is 8. Okay, time for you to try your hand at one. We've got a trapezoid. We're given the area of 210 square yards, and we're asked to find the height. So pause the video and then come back and check your answer. Well, we know the formula for the area of a trapezoid is 1/2 times height times the quantity of both the bases added together. So if we substitute in 1/2, and we don't know the height, times 20 plus 50 is 70. Half of 70 is 35. So we divide 210 by 35. The height would be 6 yards. And to wrap it all up is our concept summary with the areas of polygons and giving you their formulas. So if you don't already have this in your notes, now would be a good time to get this entered in your notes to make it easier to do your assignment. Very good. You are ready to begin working on today's assignment.